Liquid nitrogen is truly amazing. It looks like water boiling furiously, but it is not hot at all. It is incredibly, dangerously cold. This substance captures our imagination. We often see it in science shows. It creates impressive, billowing clouds of vapor. This visual drama makes us curious. However, its extreme cold is a serious matter. We must understand its hidden power. What exactly is liquid nitrogen? It is simply nitrogen gas, the same gas that makes up most of our air, but it has been cooled to an incredibly low temperature. It boils at minus 196 degrees Celsius, that is minus 321 degrees Fahrenheit. This is far colder than any natural place on Earth. Imagine the coldest winter day you know. Liquid nitrogen is vastly colder. This extreme cold makes liquid nitrogen very useful. Doctors use it to freeze and remove skin problems. Scientists use it to preserve delicate biological samples. Samples like cells or tissues can be kept for years. Chefs even use it in modern cooking. They make instant ice cream with it. These applications are clever and helpful, but the cold that makes it useful also makes it dangerous. Working with it demands great respect and care. The primary danger comes from its intense cold. Direct contact can cause immediate harm. It is not like touching a common ice cube. An ice cube is merely at the freezing point. Liquid nitrogen is so much colder, it can freeze human skin tissue almost instantly. This rapid freezing causes severe damage. Understanding this hazard is absolutely critical. Safety must always be the very first consideration. What happens if liquid nitrogen touches your bare skin? It is a very serious situation. Your skin contains a lot of water. When this water freezes very quickly, it expands. This expansion damages your skin cells. The damage can happen in just a second or two. Even the cold vapor it releases can be harmful. It is not just the liquid itself. Any exposure can lead to injury. This rapid freezing injury is called frostbite. It is a severe burn, but from cold, not heat. The affected skin can become numb. It might turn white or a grayish-yellow color. Painful blisters can also form on the skin. In very serious cases, the tissue can actually die. This is known as necrosis. This can lead to permanent, lasting damage. Sometimes amputation might be necessary if exposure is severe. You might hear about the Leidenfrost effect. This happens when liquid nitrogen hits a warmer surface. It boils so rapidly it creates a gas layer. This gas layer can briefly insulate the skin. It might protect for a tiny fraction of a second, but this effect is not reliable protection at all. Do not depend on it to keep you safe. A splash or prolonged contact will quickly cause harm. It is a fascinating phenomenon, but not a shield. Never rely on this brief, fleeting moment. Even a small amount of liquid nitrogen can be dangerous. If it gets trapped against your skin, it is worse. For example, if it soaks into your clothing. The clothing holds the extreme cold directly on you. This concentrates the cold and deepens the injury. The pain from such a burn can be intense. Healing from cryogenic burns takes a long time. It can be a very difficult recovery process. Therefore, direct contact must always be prevented. To handle extreme cold safely, we need special gear. Regular gloves are not suitable for this task. Gloves made of cotton or wool will not protect you. In fact, they could make the situation much worse. If liquid nitrogen soaks into these materials, they freeze. They then hold the intense cold right against your skin. This greatly increases the risk of severe frostbite. We need gloves designed for cryogenic temperatures. These are often called cryo gloves. Russian cryo gloves are a key example of such protection. They are specifically engineered for this purpose. They provide excellent insulation against extreme cold. Their construction involves multiple layers of materials. Each layer plays an important role in safety. The outer layer is usually water-resistant. Sometimes it is completely waterproof. This prevents liquid nitrogen from soaking through. It must effectively repel the dangerous cold liquid. Inside the gloves, there are special insulating layers. These materials are designed to trap air. Trapped air is a very good insulator. It slows down the transfer of heat, or in this case, cold. Think of how a thermos flask keeps drinks hot or cold. Cryo gloves use a similar principle for protection. They create a barrier between your hand and the cold. The inner lining is typically soft for comfort. This allows for extended wear if needed during procedures. This meticulous design is crucial for safety. The design of cryo gloves also considers overall safety. They are often made to be quite long. They extend up to cover the wrists. Sometimes they cover part of the forearm too. This protects a larger area from accidental splashes. Good cryo gloves also allow for some hand movement. Users must be able to perform tasks safely. Using these gloves is a vital part of lab safety. They are true guardians against cryogenic hazards. Cryo gloves are essential, but safety doesn't stop there. A complete safety approach is always necessary. This includes wearing a protective face shield. Splashes of liquid nitrogen can easily reach your face. Your eyes are extremely vulnerable to cold damage. Proper eye protection, like sealed goggles, is even better. A lab coat or a cryogenic apron is also important. This should be easy to remove in an emergency. These items protect your body from hazardous splashes. Proper room ventilation is absolutely crucial. Liquid nitrogen evaporates and turns into nitrogen gas. Nitrogen gas is a normal part of the air we breathe. Air is almost 78% nitrogen. But too much nitrogen gas in one area is dangerous. If liquid nitrogen evaporates in a confined, poorly ventilated space, problems arise. It can displace the oxygen in the room. This can lead to a serious risk of asphyxiation. This means suffocation due to lack of oxygen. Thorough training is a non-negotiable part of safety. Everyone who works with liquid nitrogen must understand all the risks. They must know how to use all protective equipment correctly. This includes gloves, face shields, and aprons. They must also know what to do in an emergency. Knowing first aid for frostbite is very important. Following safe handling procedures is key. For example, always pour liquid nitrogen slowly to avoid splashes. Being aware of safety showers and eye wash stations is vital. Knowledge and preparation are your best defenses. In science, we are driven by discovery. We constantly aim to push the boundaries of knowledge. But safety can never be an afterthought. It must be built into every experiment. It must be part of every laboratory procedure. When we deal with extreme substances like liquid nitrogen, caution is paramount. The need for careful practices is non-negotiable. Using the right equipment, like Russian cryo gloves, is essential. Our quest for knowledge should never compromise our well-being.